We start this course with a brief introduction to R. I tell you what it is, and at the end of the video you can proceed to Lab 1 and try it out for yourself. So what is R? R is a programming language, simple as that. I just listed a couple of programming languages here in order of popularity. The family of C programming languages is at the top. Second is Python. R is 11. And another statistical programming environment that you may have heard of is SAS, still one of the more popular programming languages in general. So programming languages are different in that they can be general purpose or they may be particularly good at something special. So R obviously is good for data analysis, statistics, but it's obviously not the only one. SAS does that too, and Python actually can do all of this as well. So you have quite a few choices here, and if you start out, one of the criteria of why you choose to start with something is the level of abstraction. So I would ask, is this a programming language where the commands are very close to what the computer actually does? So if that's the case, that's very difficult. So assembly languages are an example for this. And your commands are like, move this number to this memory address. So that's very tedious. And then higher level languages have increasing level of abstractions where your commands are actually not anywhere close to what the computer actually does in the background. So in R, you can ask for a linear model or an ANOVA, and it'll do that, and you don't have to worry about shifting bits and bytes around. So you want to start with a programming language that has a very high level of abstraction like R. Just to give you another example, JavaScript would be an easy-to-learn language for developing web apps. So most of those have at some point been considered high-level languages, but Fortran, for example, is a lower-level language, specializes in numerical and scientific computing that are not too far removed from what your CPU actually does. And the same is actually true for C. So for the original C language, it's a very low level, and the advantage of that is that it's very fast. So many R packages actually use C in the background to make things happen fast. But this is hidden from view, and it's not something you have to actually deal with. So if you're interested in statistics and analysis, this is a very good place to start. Something for more advanced users would be Python. That's a more general purpose language, but it also has all the tools and packages for data analysis, statistics, artificial intelligence, machine learning, GIS. So it's just as good and flexible as R, but it's certainly easier to start with R. Now, just to give you a slightly different perspective in the context of other statistics programs and languages. So SAS is definitely a bit of a has-been. Python is the new kid on the block with powerful tools. R is a force to be reckoned with, but let's say it's not a completely unified experience. Twitter offers some additional perspective in terms of what programming languages are as seen by users of. So the diagonal is here, the self-perception. R users see themselves as the cool kids on the block. And maybe what's interesting is that the only repeat images here are for Python. So everybody seems to agree that Python is pretty powerful stuff, except SPSS users who just don't know what it is. And R is losing some of the user base to Python over the last couple of years. But R is certainly a better place to start. That's why we use it in this course. I would also say it still has an edge for users who are primarily interested in science applications. You have outstanding tools for generating scientific graphs, and when it comes to the latest and best analysis tools for environmental and life science applications, you'll find it here. And if you're on the engineering side, or if you're a data scientist for business and commerce applications, or if you are interested in machine learning, then Python is certainly your best choice. And here, this is my last analogy, if statistics programs were smartphones, R and Python are operating on an open source license, so everybody can contribute packages. They do have some base functionality, like an Android or iPhone, but the power comes from all the apps, right? So that opens up all kinds of new functionality. So in contrast, SPSS, Data, SAS, they are all commercial companies with closed ecosystems. And while their procedures are very good and very well documented, they just can't keep up with a community of thousands of scientists, programmers, and developers that support R and Python. So if you haven't done so, head on over to the R project website. Download the latest version. If your version of R that you have on your computer is older than a year, I would say update it for this course, then you're less likely to run into compatibility problems. And with that, I would say let's get started. I recommend for this course that you just use the R base package either for Windows or for Mac OS here or for Linux, whatever you are using. The R base package is just fine for our purposes. It's very simple, easiest way to start. Now, if you already know RStudio, I do have an alternative lab that you can do. If you have already developed some muscle memory on how to run things there, then I think it's no point switching back. But if you're starting from scratch, the base package interface is going to be very simple and it gives you a really great start. I show you how to set yourself up. I walk you through this in the following video step by step. And this very simple R base package program environment will easily get you through this course and through a scientific career. So my approach to programming is keep it simple. If you need enhanced editors because you have hundreds of lines of code, you're probably doing something wrong and it could be done much simpler. So if you find yourself in that situation that for your project you have hundreds of lines of code, do talk to me and the TA and let's see if we can help you out with some tips and tricks. If you want to use R primarily with the purpose to support scientific research, you want to get it right. And keeping everything simple is the best recipe to not make mistakes, to not have bugs in your code. So that base package actually helps you a little bit to keep it simple, just because it's a fairly rudimentary programming environment. But it's great for beginners. So let's get started with this and take it step by step. Okay, so if you start the program either through a desktop shortcut or from the start menu, this is how it looks like. If you're a computer geek, you are immediately familiar. There's a command line console. But if you're not, people tend to be quite scared about this type of input. But I really don't want to scare anyone off. So what you can do is you can think of this as a glorified pocket calculator. So if you can handle a pocket calculator, this one will not be too hard. So I'm going to bring up my on-screen keyboard so that you can actually see what I'm typing. And we could do something as simple as, let's say, 2 plus 3, and then hit enter. And we get an answer, 5. So that's correct. So the other thing that we can do is we can assign numbers to variables. So what I'm going to do is we're going to do the same thing. A equals 2 plus 3, and we can hit enter again. So that's like the memory function of your calculator, and you can also query that. So we can just ask for A and hit enter, and it shows me that A has been assigned 5. Now one interesting thing is that R is case sensitive, so if you're asking for lowercase a, it has not found that object, so you have to be conscious of this. And we can also do operations with variables. So let's create a second one here. Let's say b equals 7 and enter. And now we can say a plus b and hit enter, and we get 12. Or we can assign this to yet another variable. So we can say c equals a plus b, and then we can check for c, and again 12 has been assigned to c. So I'm going to get rid of this on-screen keyboard and type directly on my keyboard. Now I think you got the hang of it. So you can use a whole bunch of mathematical functions, for example square root, sqrt of c. So that's the square root of 12. You can use power functions, so c to the power of 3 gives me 1728. Log of c. You can set different bases, so if you want the log of c to the base of 10, that's that number. So it's a pretty simple, straightforward scientific calculator, if you will. Now, the next thing you can do, and where it gets a little bit more interesting, is to work with vectors or with strings of numbers. So instead of assigning one number to a variable, I can assign a whole bunch of numbers to a variable. And so let's call this one x equals. I'm assigning this 1, 4, 3, 5, and 7. Oh, that's an error. So if you make an error, this actually, I show you this with the on-screen keyboard here. And another thing that you can do, you can look through your previous command history with these up and down arrows. So if I go up, it shows me the last command, then the one above, then the one above, and so on. So we forgot something here, and that's adding a C right here at the beginning. That means that is a concatenate function. And what it does, it simply takes a bunch of numbers between those brackets and makes a vector out of it, or a string of numbers. So it's like a column or a row in an Excel spreadsheet. That's another way to think about it. So this time it worked. And let's do this for y as well. Equals C 5, 7, 9, 4, 8. You can think of that as another row or column. And now we can do some interesting things with this. We can, for example, ask for the mean of x. So that's a 4. Or we can check the mean of y. So I'm just going up and then left with my cursor and ask for y. 6.6. And I could also ask for a t-test, for example. T-test of x and y. If these were two samples of data, you can see now that those two samples of data are not statistically significant different if your alpha level was 0.5. So I'm not going to get into this too much, but I just want to show you how this works in principle and what you can do. Now, in practice, you probably are not going to just work with a console, especially if you're like me with those kind of typing skills, as I just demonstrated to you. This is really a pain. You would never get anywhere with this. So in the next video, I'm going to show you a way to work a little more efficiently in R.